So just an illustration of this multiple event conditional probability. We have two events S and H. We also have two events of B here. Okay, so if you look at this, we have a population of 75. 70 of them has a chance of having event H. 5 of them has a chance of having event 5. But within this population, let's say, we have another event B where for this case the probability of B given of H is equal to 5. The probability of B given of S is equal to 20. Yeah. Sorry, in this case then we will have in total 100 population. Event S solely will be 25. If event H solely will be 75. Where do I get this 25 of event S is 20 plus 5. Where do I get 75 is 70 plus 5 here. So if you want to calculate the probability of event S given of B, so probability of event S given of B, right? We have B, but how many of them are S? This will be equal to, if you look at this Venn diagram, the probability of S given of B technically will be 20. So within this B, there are 20 of them are S. Within this 25 of B, there are 20 of them are S. So the probability, just looking at this diagram, we can see that the probability of S given of B will be equal to 20 over 25, right? 20 over 25, 80%. But let's try to calculate this, the probability of S given of B, by using the formula. The formula says the probability of S given of B will be equal to probability of S and B occurring together divided by probability of B. Probability of S and B occurring together will be probability of B given of S times probability of S, right? This is the simple first formula that we discussed before. Probability of B given of S, right? Probability of B given of S will be 20 out of all of the S's. 20 divided by 25 times probability of S. What is probability of S for all of this event here? Probability of S will be all of this S, which is 25, 20 plus 5, divided by all of the possible events, 100. So this will be 25 over 100. Now we calculate probability of B. Probability of B, we can calculate it by calculating the total probability of B, which is equal to probability of B given of S times probability of S. This part actually is equal to the denominator, equal to the numerator part here. We have calculated before. And the second part here, probability of B given of H times probability of H, we can calculate it again here. Probability of B given of H, so we take a look of all probability of H, and among these H events we have 5 events that is a part of B, right? So the probability of B given of H will be equal to 5 over 75. And probability of H is just simply a probability of H among all of the events, which is 75 divided by 100. If you multiply all of this, you will end up into 20 over 25 or 80%. This is exactly the same number that we calculated directly from this diagram. The probability of event S given of B then will be equal to 20 divided by total of probability B, 25. Okay, so we can calculate these with these two approaches. Directly you will calculate it, or if it is becoming too complex and you only know the information partially, you can calculate it using this formula. Okay, this is another example when we have more than one, more than just 4 events. We have multiple event case here. You want to calculate the conditional probability. So we have 2 events, 2 main events, S and H. The occurrence of event S will be 2 plus 8, 10 plus 12 plus 3, it will be 25. The occurrence of event H will be 60 plus 5 plus 1 plus 6, which is 75. So the total events will be equal to 100. And then now we want to calculate the probability of S given B and C occurring together. Let's try to calculate it without using the formula. Just look at the diagram here. Let's identify first which is B and C occurring together. B and C occurring together is this part, right? B and C occurring together, 13. And we want to calculate probability of event S given that the event is within this B and C. So the event S within B and C will be 12 out of this 13. So technically then, looking at this diagram, the probability of S given of B and C occurring together will be 12 over 13. But let's calculate it using the formula. So first we use this formula. This is derived from a simple conditional probability relationship. If this is S is A, B and C is B, so the probability of A given of B will be equal to probability of A given of probability of A and B occurring together divided by probability of B, the one that we have in the first few slides, right? So let's start to calculate the numerator first. The numerator here we can calculate it using the chain rule. Probability of S, B and C occurring together will be equal to probability of S given B and C times probability of B given C and probability of C. Probability of C is equal to this 1 over 100. So this part will be equal to 25. So probability of C will be 25 over 100. Probability of B given of C, so probability of B given of C, we have C, and 13 out of it is part of B, so probability of B given of C will be 13 over 25. And the last part is probability of S given B and C. B and C is this is B and C, B and C is this, right? And probability of S given B and C, so S, that is a part of it, it will be 12 divided by 13. So you can calculate the probability of S and B and C occurring together. And then for the denominator, you can do the same thing, probability of B and C occurring together. Okay, probability of B and C occurring together. Technically, if we look at this diagram, probability of B and C occurring together in this universe, then it will be 13 divided by 100, right? But let's calculate it using the formula. Probability of B and C occurring together will be probability of B given C and S occurring together times probability of C given S times probability of S. So this is the chain rule of probability B, C, and S, and plus the probability of B, C, and H. Yeah. So this basically, if you look at the denominator, this is the total probability, where each of these probability, these two terms, is calculated using chain rule. Okay. So if you put all of the number down here and you calculate it, you will end up into 12 over 13. This is exactly equal to the probability that we calculated before just by looking at the diagram. Okay, you can stop it here, pause this video for a while, and then try to understand how we calculate it, and then you will get a better idea on calculating this conditional probability for multiple events. Okay, and then we will continue to the next slide in the next video.